All right, we ended Monday with this projectile motion simulator. We have an equation up here for our horizontal position. That was just the red dot, and that's long 0 because the y-coordinate is always 0, and then there's that comma. And then our x position is our horizontal velocity times time. Now this is actually a big idea, because when we say that, what we're saying is that the horizontal position of this projectile does not have an acceleration. It's a constant velocity. So if we look at this, our x position is going to be just equal to vxi t. Now you notice that in these equations here, a lot of times we have a delta x, but since we're starting from 0, delta x is going to be the same thing as x, because delta x, remember, it's just x final minus x initial. And if our x initial is just 0, our position x final, or whatever x is with t, just becomes x. And so sometimes we just shorten that up to x. So we'll just write that as x equals vxi delta t. And normally here we also have a plus 1/2 ax delta t squared. But when we say this is a constant velocity problem, and just this part, what we're really saying here is that the horizontal acceleration is 0. So this is an important thing to remember. When we're talking about projectile motions, our horizontal acceleration is 0. And the same way, since the vertical is going up and down and gravity affects it, that our vertical acceleration, ay, is going to be a negative. Negative 10, in this one case we did, to make the numbers a little bit easier for you to solve. Sometimes we'll say it's negative 9.81, which is usually what we do. And most of our other problems we'll do negative 9.81 because the numbers won't be as nice. But this first one we just start off at negative 10 just to round it and make the numbers a little easier for us. All right, so, well, there's our equation then for our x. Our x position is just going to be vxi delta t. All right, our y position, and that was the green dot. And, we can see that this is moving up and down as we do things. All right, so the x is just moving constantly horizontally. That's the red dot. And the green dot is moving up with time, and then it slows down, and then it moves down with time. And that's an accelerated motion, this green dot. And this is problems that we've done before. It was actually one that was on your test, which was something's launched up vertically, and then what does it do? How do you analyze it? And so these ones shouldn't be too bad. So the green dot here, now we have x is 0, because that just keeps the dot on the y-axis, and then the comma and our y-coordinate. And now this one's a little bit more complicated. We have y is equal to yi, which turns out to be its initial height, plus vyi delta t plus 1/2 ay delta t squared. Now, some people are like, well, what's this y stuff? Well, you remember here that this equation originally was delta y equals all this stuff up here. All right, but what is delta y? Well, delta y is y final minus y initial equals all that stuff. So if we just solve this for y final, we get y final equals, the y initial comes over as a positive because we add y initial to both sides. And then we have plus vyi delta t and all that stuff. So when we're saying y equals y initial, what we're really just saying is we're using the equation for delta y, and we're bringing this y initial over for us. So that comes out to be not too bad. And this shows up in a lot of our problems. All right, and then when we put those two together, we get the blue dot. So now we have the x coordinate, and it's hard to see, but there's a comma there. And then we have the y coordinate. And so x comma y gives us that projectile motion. And we showed, not real rigorously, but we showed that we can get the projectile, we can get a parabola to match that. And that we just had to adjust our x. We had to scale our x. When we do this traditional y as a function of x. Now we converted that. We took time away, and we just showed its path overall. And you don't really have to understand why it's x over vxi, but that's kind of interesting that we scaled the x to match our time horizontal position function. All right, and then your assignment was, we're supposed to line up with 30, 10. So we want to hit this point here. And you could do that by all these things we can adjust. So we have this time, so we can see as time goes by, the projectile shoots and then it comes down. All right, but we could adjust all these other things to see how do we hit that point. Now we're not going to adjust ay, we're going to leave that at negative 10, but you can adjust the initial height. So this is the height at 0, right? So now it's at 17.6. Now the initial height's at 23.4. And so that's the position, the height at time 0. So there's 23.4 when time 0. So it's where we're shooting from. And then we also had the vertical and horizontal velocity. Of course, if we're shooting it with less vertical velocity, it's not going to go as high. We could even go down to 0, which would basically mean that we're shooting that horizontal projectile just straight out. And then gravity's taking over, of course, and pulling it down. We can also change the horizontal velocity. And you can rescale this too if you want, if you want to go up higher than, have the slider go higher than 20. So we can, scale that up. So it looks like right here, we can actually hit that pretty well, and get close. And so then you can play with it. You can be like, all right, how close can we get? You can move these sliders around. You can adjust them, and you'll get pretty close. So, and our job was to get 2 different ways to get 30,10. So there's lots and lots of different ways. Some of you sent me some emails like, how close do I got to be? Is this close enough to 3010, 30.03, and 9.77? And I said, whoever responded, I said, don't worry about it. Get as close as you can. Wednesday, which is today, we're going to look at how can you solve for it. Okay, so we're going to do that next. How can we actually get a solution and solve for these different things? Well, the first thing we got to look at is when we do projectile motions, there's a horizontal and a vertical problem. So if I write out the horizontal equation, I get x equals vxi delta t. Or if we want to just put t down, because shorten it, we can do that too. And then we have y is equal to the bigger equation, yi, plus vyi, the initial vertical velocity, times the time that goes by, plus 1/2 ay delta t squared. All right, and so you should be used to these. Now, there are 2 different equations, one for horizontal and one for position, but they happen at the same time. So these things are bridged, this horizontal and vertical motion, they're bridged together by time because they happen together. As you're going up and down, you're also going sideways, and that's what gives you the parabolic shape. And so we can use that idea to solve for things. So right away, the easier equation is x. And so if we think, okay, when is this thing going to get to 30? Because that's when we're at the distance that we need. So we can solve this right away. We can say, look, x over vxi is going to be delta t. And here again, we want this x to be 30. So if we're going to solve this here for hitting that spot, the orange spot, 30,10, we would say, okay, well, whatever happens, 30 over vxi, that's going to be the time it gets to 30 meters from our start, horizontally. And so right here, we got a nice little solution here. So we can figure out how long it takes to get to 30. We can plug that into our y equation right away. So we can throw this up here, and we get y equals yi plus vyi. Now I'm going to put in for delta t, I got 30 over vxi. I'll put that in a parenthesis here just so we can kind of see that that's what delta t is. Plus 1/2 ay. And again, that parentheses, we get 30 over vxi squared. Okay, and now when we look at this equation here, clearly we want y to be 10. And if we look at what do we got here, we got one equation and how many unknowns? Well, we got, let's change colors. We got yi, let's put a dot there. Yi is 1, vy is another, and vxi. So I'll put an arrow connecting those. So we got yi, one parameter, vyi, another parameter, and vxi, a third parameter. We're not going to count ay because we know that's acceleration of gravity. That's set at -10. So here we have one equation and 3 unknowns. That means there's lots of different solutions for this. And so what we're going to do to start off here to find out a solution is let's just pick some values. We can just pick 2 values because just like you guys could set the sliders for vyi or vxi pretty much for anything you want to solve it, we can do that here too. So let's see, I picked mine, let's do an initial height of just 5 and an initial vertical velocity of 20. And we'll just throw those numbers in and then solve for the vxi that will get y at 10 meters when our x is at 30. So when we put in this delta t in here, we're saying, all right, we want x to be 30, and then we put a 10 here in for y, we're saying y is going to be 10. So if I rewrite that out here, I got 10 is going to be equal to 5 plus 20, 30 over, put a dot there, VXI, plus 1/2 AY. Okay, so AY here was negative 10. So I'll just do that math. Plus 1/2, so that'll be minus 5. And then we got 30 squared over VXI squared. Well, 30 squared is just going to be 900. All right, and then we over here, we got VXI squared on the bottom here. So, and now this is not looking too bad here. We got our variable in the bottom. Let's clear that out by multiplying both sides by VXI squared. And when we do that here, we get 10 VXI squared equals 5 VXI squared plus 20 times 30 is just 600. And we multiply by VXI squared. One of them's canceled out by the VXI on the bottom, so we just get one VXI left on top. And then we have minus 5 times 900 would just be 4,500. All right, so this is looking like a nicer equation just for quadratic. I'm going to go on here and give myself some more space. Oh, I don't want to erase all of it. Oh, well, okay, I'll erase all of it. Let's see. And we write that down here. We bring, let's see, we get 0. If we bring that 10 VXI squared over, we get minus 5 VXI squared. Then we get, let's see, was that minus or plus 600 VXI and then minus 4,500. All right, so this is a quadratic equation here, which means even though we already picked, remember here we picked a y to be 5, and a VYI to be 20. Those are the numbers that I picked, so I'll have to put those in later. But even with those numbers, it looks like we have 2 solutions, possibly, depending on how this quadratic looks. So, you know, we can simplify this. We can try solve it. You can do it different ways. A lot of you kind of like to maybe do some shortcuts here. We can simplify this. If we divide everything by negative 5, we get 0 equals VXI squared. 600 divided by negative 5 is going to be negative 120 VXI, and 4,500 divided by negative 5 is going to be 900. All right, so now we got a quadratic equation. Well, here's our x value, that's squared, x squared, and so we got our AB plus C. We can solve this. All right, let's look at a different way to solve it here. Let's use decimals to solve it. First, I wish I could, well, yeah, maybe I can. I'll turn this off here. So now I can go over here and I can put in my numbers here. So YI was 5, VYI I'll put in here at 20. And now we can look here, are there different VXIs we can put? Well, it looks like one hits here around 8. And it looks like if we, whoa, it looks like if we shoot faster and faster, I guess I gotta go up to, I don't know, let's see, 200. I'll just put the slider up high. And now I can, looks like, yeah, somewhere here around 110 or so, I'm going to hit that thing again. So I can hit it with the horizontal velocity of VXI of like 110 or so. Or I can also slow it down to, you know, maybe 8, and then I'll hit it also again. So whether I hit it on the way up or the way down, we can find that out. So let's solve this here. Oh gosh, let's get that put away. Why do I have this big thing? Oh, it's a tablet. All right, so I need to solve this. So let's just graph it first here. Y equals, if I graph that quadratic, I get x squared minus 120x plus 900. Okay, and so right here, I got a quadratic. It looks like a big quadratic. I'll zoom way out. Whoa, so there's my big, tall quadratic. It goes up really high. So there's the bottom down here. So it does have 2 solutions. And I can look at what those 2 solutions are. 111.962, right? That's around 110. And then our other one here was 8.038. So we sit around 8. So that works pretty well. I can put those values in. 8.308, let's put that in here for VXI. 8.038, was that what it was? 8.038. And it looks like we're hitting right on there. That looks pretty good. Also, we have this other solution here. Oh, it's off the screen. The other solution here at 111.962. Let's put that in and see if that works. 111.962. Well, that looks pretty much right on here too. We can try, get our time here until it comes right in here. 30.023. It looks like it's a little bit smaller. I can type these in. All right, so that's looking pretty good. I mean, even more specific. I have 7. I'll put a 5, 7, 6, 7, 7, 7, 8, 7, 9, 7, 9, 5. Oh, there we go. So I'm playing with the time a little bit. We got 30,10. With our one solution, and let's see, 8.038. I'll put that in here, 8.038. Let's see how close we, oops. Ooh, VXI equals 8.038. All right, so that matches up here, 8.038, 8.038. And then I didn't do the subscripts right. Got to do the underscore XI. There we go. All right, so we got our parabola back. It looks pretty good. Let's see if we can get the time just right. So as we come through here, and looks pretty good. Let's see, I'll go in here and edit 9.4. That's too high. 9.3, 6, 3, 2, 1. Oh, we're getting close. 2. Okay, so it looks like here we're having a little bit of a problem because I'm not quite there. Awfully close though. We're getting there. Let's see. So 2, 1, 1, 2. We got a little bit of rounding apparently. Say 3, 4, 3, 3, 4, a little too high. So 3, 2, 7, 2, 8, 2, 9, 2. All right, so here is we're not quite getting there, and so we're kind of going too far. So we can think here, well, what's wrong here? Well, one answer may be because this 8.038 is rounded. And so we can think about, okay, how do we get past there? And we can say, well, maybe we need to do a little bit better here on, let me put another window in here. Let's drag this down. Okay, so if we want a better solution than these intercepts that we can pull off, we can do the quadratic equation. So it's going to be what? Negative b. So negative 120 will be 120. Plus or minus, I'll start with plus. The square root of b squared, so 120 squared, the negative takes care of itself, minus 4 times a is 1, times c is 900. All right, and then we got to do that whole thing over 2a. So it would be over 2 times 1. All right, and so here we get that solution, 111.9615. All right, so now we can put the minus in here instead. And we get our answer. So 8.038. Oh, so look, there's 475. There's some more numbers coming after there. So if I put that into my here, so 8.038, 47577. I guess I might as well do all of it. 2293. Okay, so we got that in there now. And now let's see if we can play with time. Well, we're getting a little bit better here. Let's see, I'll back up a little bit. So it's 3, 1, 3, 2, 3, 3, 3, 4, 3, 5. Let's see, 3, 6. Am I getting bigger or smaller? Too far, too far. Okay, so I'm at 30. I'm real close to 10.01. 1 is too far away, so let's see. Ooh, we're getting close. Oh, that gets us farther away. So we got to be a little bit less. Let's say 2.1. Let's do 2.19. Ooh, we're getting real close here. You guys are probably going crazy with this. 10.01. So that's a little too, let's see, 2, oh, 2 and 0, 1, 2, 3. Oh, there we go. 3. All right. So I had to play with the numbers a little bit. And I got the 30, 10. So just perfect. So these are two ways that you can solve these problems, or at least one way you can solve these problems. You solve for, what we did first was we solved for our time. If we know its final position horizontally, we can find the time that it's in the air, and then we can use that time to go into the vertical equations and solve for our other variables, whatever they are. So one different way, and then we'll give you some homework assignments on those. I'm sure you'll have lots of fun. Okay, look, we kept it under 10 minutes, or just about. All right, that was a lie. Just over 20 minutes.